Okay, guys, today we're on 13-4 Relations and Functions on page 358. The objectives here are to identify the domain and range of a relation, to identify a given relation as a function or not a function, then to write an equation to represent a function from a table of values. Okay, so we've all seen this, right? An ordered pair, or a coordinate on a coordinate plane, is x comma y, right? So over here, we have 5 comma 7. So this is our x value. This is our y value. Okay? So I don't want you to write down here all these ordered pairs. I want you to label them x and then y. So let's do it together. If you need to pause the video, you're more than welcome to write down all the ordered pairs and then we can label them together. Okay, so we have, x, y, x, y, x, y, x, and then y. So all of our x values are going to be these little brackets around. Whoa, that's not a bracket. Biscuits. Put these brackets around. So we have 5. What am I doing? 5, 1, -4, 3, and 2. These are all of our -2. These are our x values. And our y values are going to be 7, -8, 0, 9, and -6. Okay, so remember these types of ordered pairs are things that you would use whenever you would play Battleship as a kid, or if you're still playing Battleship, which I think that is a cool thing. Okay, so these are all points on a coordinate plane. That's what this is leading to. Alrighty, so a relation is a set of ordered pairs that associates two quantities in a specific order. So the x and y value, right? So along with x and y value, it's going to talk about domain, input values, range, and output values. So when it's talking about x, it's talking about also a different word for the x value is the domain. Okay, it's also referring to the input values. When it's talking about the y coordinate, it's talking about the range and the output values. Okay? Alrighty, so I want you to check out the type of relation chart on page 358 with the purple heading. It says type of relation, description, and example. This kind of goes over what a function is, which is a set of ordered pairs, x, y, in which there's only one y value for each x value. Okay? So if we take a look at that chart, it says 1 to 1, 1 to many, many to 1, and many to many. You don't have to put that whole chart down, but those examples are really good as examples of functions and not a function. Okay. So a good way to see if a relation is a function is to pair or map each input value or x coordinate or x value with its corresponding y value or output value. Okay? Okay, so for instance, when I set these up, I didn't actually write out the ordered pairs, but it would be like 1, 3, 2, 6, 3, 9, 4, 12, and 5, 15. So you set them up like that. Okay, the only way that we can say if these ordered pairs are a function is if there's only one y value for each x value. So it's going to look like this. 1 goes with 3, 2 goes with 6, 3 goes with 9, 4 goes with 12, 5 goes with 15. So this is a function. Okay? Alright. So same thing here. So I got this from the chart on the blue chart at the top of page 359. Alright, so 24, when you look at that chart of average temp and then the day, 24 does go with M. 32 does go with Tuesday. 30, if you look at that chart, is both for W and for Wednesday and for Friday. So it goes boom, boom. Then 34 goes with Thursday. Okay? So we have a problem here. Because if you see, 30 is paired up with two y values. 30 is paired up with Wednesday. and it's also paired up with Friday. So there's 2 y values for 1 x value, so this is not a function. And once we start graphing these coordinate points in these ordered pairs on a coordinate plane, you're going to see exactly why it's not a function. It's just a little hard to understand now because I don't think you've ever seen it before. Okay, so let's start talking about a function rule, which relates the input x values to the corresponding output y values. So we have number of hours and number of miles. So this could be for anything. It could be for driving. It could be for walking, running, whatever. So for every hour, for the first hour, second hour, third hour, fourth hour, fifth hour, it tells the number of miles that have been traveled, right? So a function rule is kind of going back to what we've done the past 2 sections with patterns, okay? You're going to look for a pattern between the input and output values, okay? So for the first term, it's going 55 miles. The second term, it's going 110. And the third term, it's going 165. So I want you to just stop the video right now, and I want you to think of a pattern that could apply to this particular table. Okay, so first what I'm going to do is I'm going to say that x equals my number of hours. And y equals my number of miles. Okay, I depend on my number of hours because I wouldn't be able to walk any of these miles if it wasn't for the time that I take to walk or run or drive those miles. Okay, so I hope you found a pattern. I hope that it wasn't too hard to find on this bad boy. But if you look at it, each output value is 55 times the corresponding input value. So 55 times 1 is 55. 55 times 2 is 110. 55 times 3 is 165. Times 4 is 220. Times 5 is 275. So we would put that y equals, because to write a function rule, you're going to put y equals first. So y equals your function rule times x in this particular one. So it would be 55 times x, because it's 55 times my x value, which is up here. These are all my x values. These are all my y values. So y equals 55 times these numbers. Our first one is 55, so 55 times x, which in this case would be 1, is going to be 55. 55 times 2 is 110. So you would just plug in these values to make sure that's correct. So let's do this one. Let's do our last one. So if y equals, so let's do this last one, 275, equals 55 times x. Divide by 55 on both sides to solve for x. X is going to equal 5. Okay, so this is a true function rule. I know this is a little weird, as we've never done this before. So just slow down, take your time. We'll do a bunch more examples in class to kind of explain what all this stuff actually really means, because it's hard to give you hard and sound examples here in the video. Okay, so right now I want you to pause the video, and I want you to say if this set of ordered pairs is a function, if this set of ordered pairs is a function, and then if this set of ordered pairs is a function. Okay, just put F or N. If it's a function, put F. If it's not, put N. Okay, good luck. Check back in a second. Okay, so I'm hoping that you spotted in this first set of ordered pairs that we have a repeating 3 for the y value. So this would not be a function. Not a function, because I have a 3 here and a 3 here. Okay? Not a function. Down here, this would be a function because I have no repeating y values. Okay? Down here, this would also be a function because, again, I do not have any repeating y values. Now, I could have the same x value. I could have 1, 5, 1, 7, 1, 6. I can have as many of the same x values as I want, but I can only have one y value per x value. Okay? Alrighty, so this is where we're leading to next, the coordinate graph. Okay? So this is where we would apply the function rule, a function table, the domain, the range. So if you recall, this horizontal line is your x-axis, and your vertical line here is your y-axis. Okay? Our origin here is 0, 0. 0, 0. Okay? These are positive numbers over here. These would be negative numbers over here. Positive up top, negative on the bottom. Okay? This is our quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay? Alrighty. I would like you to, let me change this up, to try these 1, 2, and 3 in your notebooks. Try these 1 through 3. And I also want you to answer this question. What character was on the very first slide of this video? What character was on the very first slide of this video? Okay, good luck. I'll see you next time in class. Bye, guys.